Hello, in this session we are going to see how to input the data into HEC RAS and how to run the model, and particularly we can we can export data or import data into HEC RAS in one of two ways. The first one is if you are given with the topo map or digital elevation models, you can create a tin map or triangular regular network map, and you can export that into HEC RAS in a GIS format, and then you can work on that. The other perspective is if you have a surveying data, field collect surveying data, you might choose to input them manually, and or you can create a digital elevation model from the surveying data and do the procedures you do in HEC RAS. So in this case, we are going to use the surveying data collected from Kulfo. So this is the data. Data is for the Kulfo River, and we have the easting, which is the longitude, and the northing, which is the latitude, and the third dimension, which is elevation. And we can add an ID into this system, like a data ID, in order to identify the data. So just can give them number and non-repeating numbers. So the first step is to see which points are on the in a cross section. So we don't know 1, 2, 3, 4 are in the displaying the same cross section, or 5, 6, 7 is displaying the same cross section. So if you want to know which points are in the values for a given cross section, you have to try to plot this one on a GIS and see what it looks like. So what I am going to do is I will add my data into GIS. So for that, you can simply go to add, and then add the data from wherever it is located. For example, mine is in HEC RAS practice 2. It's surveying. Then surveying is only sheet I have in there. So in order to view the data, I come here and right click and say display the data. So when I display the data, I should tell which one is X and which one is Y. So in our case, X is represented as a longitude, which is easting, and Y is represented as a latitude, which is northing, and Z is the elevation. So here you have easting as X, and you have northing as Y, and you have the elevation at Z. And you have to you have to edit your coordinate system if you haven't selected one yet. So in this case, our data are given in meters. If the data are given in meters, it implies that or in meters or in a length dimension, it implies that the data is of a projected coordinate system. If your data is given in latitude, longitude, in a decimal degrees, then it is a geographic coordinate system. So we have a projected coordinate system, and the UTM is a universal traverse Mercator, one of the most widely used projected coordinate system. And then inside there you have Africa, if you come back to Ethiopia. So there are several divisions in Africa itself. Ethiopia is located in two zones, zone 36 north and zone 37 north. So most part of the Ethiopia lies in zone 37 north, but some of the western parts, usually the Bara-Okobo, parts of the Bara-Okobo basin, and parts of the Abai basin falls in the zone 36 north. So for this one, this is Arba Minch. Arba Minch is in the zone 37 north because the river is Kulfo River. So you can add that and apply and say okay. And then you have your coordinate system here, and let's say okay. So here is a point is being displayed in the form of shapefiles. So you have to our objective is to see which ones are in the same cross section. So to see that, we have to label them, and to label we'll first go to properties, okay, and we have to first go to we have to go to properties, and and label, and under label you have the labeling field. So would you like to be with ID, with listing, with zeroing, or with elevation? So the non-repeating parameter we have of this four is the ID, because it is a number 1 to 3, and we set that as this, and come here and right click and say label features. Then you will see your pointers being featured accordingly. So for example, which means this indicated that point 10, 9, 3, 2, 4 forms one cross section, and point 12, 11, 6, 5, 7, 8 are another cross section, and this one's another one, this one's another one. So basically we have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 cross sections. So of this data, if you want to do the HEC RAS analysis of the data we have, or surveying data we have here, we have to collect them into the same categories. So for example, if you see cross section 1, we have 10, 9, 3, 2, 4. So 10, 9, 3, 2, 4, you have to collect those into one. So here we have 10, okay, we have 9, we have 2, 3, 4. So these are in the same cross section. We have to collect them, and say this one, rename this one, and say this is cross section 1. Okay, and then paste your data here. So this is for the first cross section, and you have to see the order. So the order is 10, 9. If you see it from this side to the left side to the right, so we have 10, 9, 3, 2, 4. We can write them accordingly. So there is a 10, then 9 comes second, and then 3, 4, 2. So this is 10, 9, 3, 4, 2. So 10, 9, 3, 4, 3, 2, 4, sorry. So 2 is in between 3 and 4. So you can see this is your cross section. This is the point, this is the ID, and this is your resting, and this is your northing, and this is the elevation. So now if you want to see the cross section of your valley, you can draw the x thing, which implies the x and the elevation together, and you can see what the cross section looks like. So if you plot that, so this is your cross section. Okay, this is your cross section, and you have to find a cross section 2, okay, in the similar way. For example, here we have 12, 11, 6, 5, 7, 8. So you have to come here and collect 6, 5, okay, 6, 5, 7, 8, and 11 and 12, okay, and then rename this as a cross section 2. So here is your data, and this is a cross section 2. If you want to see the cross section 2 shape again, you can plot x versus elevation. Okay, you can always see what it looks like. Okay, sorry. This is your x. This is your y. You have to see the order first. So the order is 12, 11, then 6, 5, 7, 8. 12, 11. Okay. And 6, 5, 7, 8. Okay. You can see it here, 12, 11, 6, 5, 7, 8. 12, 11, 6, 5, 7, 8. So now you can draw this one versus this, and you can see the shape of your cross section. So this is what it looks like. So this is cross section 2. Just like that, you have to collect all the pointers, okay, in a similar way. So for cross section 3, cross section 4 up to cross section 10, you have to collect the data, and the data is collected that way is here. So here is for cross section 2. For cross section 1, this is your data. Okay, the data are collected in a similar way we've seen before, and this is the cross section, and the cross section 2. Okay, this is what it looks like, and you can see for cross section 3, you have to plot for all of them because we need the plotting for some other purpose. So these are your 10 cross sections. Cross section 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So you have it all. So now this is what we have, and we can now start working parallel in the HEC RAS then with our Excel. So here is our HEC RAS. Okay. Under any project, under any software programs, the first thing to do is you have to save your project first, or create your project first. So in this case, we are going to say new projects, and we have to save a place, search a place to save. So let's go to D in the courses softwares, and can create another new folder. Okay, create a new folder, and HEC RAS new. Okay, so this is our folder, and we can create the name now. So the title is HEC again. We have HEC RAS and Kulfo. Okay, so here is the title being accepted. Then say OK. So it's saying that we're starting new projects. We might need to set our SI unit, so that's good. You can go to option, and you can see the SI unit. So we have the system international metric system, so that is okay. So we have created a project, and as soon as we create a project, you see this title, and you'll have to see your title here, and you will have to see the locations where the file has been saved here. And now we have to go through these parameters one by one in order to come up with a result. So this is to create the geometric data, and this is for the steady flow data entrance, and this is for the unsteady flow data. And here you have the unsteady flow data again. This is a quasi one, and this is a normal, and the sediment data. And then so you have a number of functions that the HEC RAS can do, but what we are going to do in this case is to see how we do the river modeling or hydraulic modeling. So you can run your model with a steady simulation, with the unsteady one, and with sediment transport and with different conditions, and you can view at the end of the day you can view your files in one of these forms. So now we have to go to the geometry, because we need to create the geometry of the valley first. So this is the geometric data entrance point. So first we have to create the river reach, random river reach. So this is you click on the river reach here. In these directions you have the junction creation points, cross sections. If you have additional structure in your rivers, you can enter them from here. And to create the river reach, you just come here and you'll have a pen, and this will be drawing area. So you can just pull it from one direction to another, and when you reach that, just double click it, and it will ask you to input the river and the reach name. So our river is Kulfo, that's obvious, and the reach is like around limits, and say okay. So immediately you will see your designations here, and then we have to input the data now. So when we input the data, we have to input the cross-sectional data separately. We have to input the characteristic parameters also, and then finally we can run the model. So now we have to input the cross-sectional data first. So before that, let's save this geometric data. So this is save a geometry data, and under the same folder, let's say this is a Kulfo geometry. Yeah, so we can save with that, and now we can create the cross sections. So this is a button where you create the cross section, and here you can create a cross section with different properties. So the data we are going to input to create the cross section is the station, which is the x values, and the elevation values. So with that we can do our work. So first to add a cross section, you just have to come to option, say add new cross section. So the naming will be only in numbers. So we can say cross section 1, we can start from top, okay, and say okay. So we have cross section 1, and then here we have collected the data for a cross section 1. We have it here. So this is the station data, and this is elevation data. And copy them, and we need to collect them together here. And then you copy these data, and when you come to HEC RAS, you have to select some part and then Ctrl+V, then your data will be pasted. Then if you want to view this data, just come here and say apply data, and immediately you will see your stations in meter and elevations in this axis for HEC RAS Kulfo. This is a particular cross section of our river at cross section 1. So now we have like 10 cross sections, as you can see from this one. We have 10 different cross sections. We have to input them one by one. So here is cross section 1. And then if you want to add another cross section, you go to option again, say add new cross section. So this is cross section 2, and then okay. So I have to go find the data for cross section 2. So this is a cross section 2, and I have to copy these both datas, and then these are them. Okay, so I have to copy this and bring to HEC RAS. So you select this part to some extent and paste your data. Let's see what the cross sections looks like by saying apply data. And then we have to create 8 more. So add new cross section 3, and say okay, and go back to your Excel sheet. This is testing data, and this is the elevation data. Copy them first and bring them together in order to make suitable for pasting. So copy this one, okay, and you can paste it on your HEC RAS. And say by saying apply data. So this is your cross section. So you see that there is a problem with the data at 33.9 to 47.4. The data hasn't been arranged in increasing order, so we have to check that 5 and 6. So if you see this one, this is 339 to 48.01. This is 47. This is 47. So these two data should obviously come after this point. Maybe there is a problem. This is a problem when I'm collecting the data. I think so. So we have to leave the elevation as it is and correct this one, because it should be at the end of the data, and now it is okay. Because as you go from one cross section to the other bank, there must be an increase in the x-axis. There is no deformed shape of a river. So you can come to cross section back and change this data. Okay, and let's try it again. So it is good now. It is corrected. So add the 6-1. 6 cross section, copy this one, and let's see if there is a problem like the first one. There must be an increment in x value. 20, 42, 46, 52, 59.38, 59.535. So these two should exchange. Okay, because should be in an increment order. And I'll copy that and go back to your HEC RAS. And this is the data for station 6. So this is a valley, and create another one. So this is the last one, 10, and is our cross-sectional data for 10. Only few. So this is our final data, and we have created the bank, the cross-sectional data. Now we can save this one. We can exit editing, and we have to save the geometrical data that has been created. So save the geometry data, and it has been saved. And so now we have to we have created the cross sections, but at what distance difference do the cross sections exist? If you see, for example, the lecture notes, for example, this one. So if you have a cross section, if you have sorry, yeah. So if you have the cross sections, so you have to know the distances or difference of the cross sections. So for example, if these are your cross sections, okay, so this is how much is the distance between cross section 10 and the cross section 9.9. So we have to find this length, and it is called the reach length, and we have to find that distance, and that distance can be found from the y data. And when we find that, we have to find it at the center of the cross section, and at the right side and at the left side of the cross section. So we need 3 pointers at every 3 y pointers, and 3 y points at every cross sections. So in this form, if we go back to the cross section 1, okay, so we have to label these values with an elevation. First, label them. Okay, let's say add labels, data label. So we have labeled that. So the lowest point will be considered at the center line of our river. So the center line mean the central valley cross section. So this center line is 1229.88. So you have 1229.88 here, and so the y value you have to use as the middle of your river should be this one. So this is at the mid of your cross section. And on the left bank, you can consider this left bank 1232 and 1232.24. you have this value of y, and in this direction you have 1230.64. you have this one. So we can take these 2 pointers at the 2 search values. So here is what you have. Here is what we have. So this is at the mid, and here is from the left bank, here is the mid, and here is the right bank. So you have to create such pointers, three pointers at the center, at the left bank, and the right bank for all cross sections. So for cross section 2, it is being collected that way, and you have it here. And for cross section 3, you can label this, okay, and I see the central cross section, the central elevation to be 1229.46. For 1229.46, read your y value here, and then put it here. And for left bank and for right bank extents, again you have to collect that in a similar way, which means at 1231.63 you have this y, and at 1232.64 you have this y. So, and then the 3 of them are being collected here, and then in a similar way you have for every cross sections. So those data should be collected for every cross sections. So up to 5 we have, and at 6 you have to label this. Okay, so this is the center is 1229.41, this one, and we have to pick this. And the left bank is 1231.51, which is this, and this is our y value. And the right bank is 1230.46, this, which is this our y value. So we have to pick this and take it separately. So this is our left bank, This is our right bank, sorry, the middle, and this is our right bank. Okay, and at cross section 7 you have to do the same thing. Add labels, and let's see the elevations. 1229 at the center, 1231.13. This one is at the left bank, and 1230.17 at the right bank, and at the center we have 1229.17, which is this one. So we have these three again, and then here, so you have the left bank, the middle, and the right bank. And then again you come here, you have to do the same procedure, label them. Okay, see your right bank's 1231.09, this left bank, the right bank is 1230.65, this, and the middle is 1228.99, this value, which means this is your y. Then there you go, you have your left bank, you have your middle, and then you have your right bank. Okay, and then cross section 9 you have to label in the same way, and then here is your left bank, and here is your right bank. So here is your left, and here is your right, and 12.85 here is your center. Then you can paste your data here. So this is the left bank, middle, and the right bank. Okay, and I go for 10. So these are the collected data: the left bank, the middle, and the right bank. So you have these informations, and you have to collect these informations at one place. So when I say that, for example, here we have to collect for all the cross sections. So for cross section 1, so this is what we need. Okay, here for cross section 2, this is what we need. And here for cross section 3, so here is your value. For cross section 4, for cross section 5, for 6, for 7, for 8, so here is your data, and you can remove these ones. Okay, you can remove these columns except this one. You can delete them. Okay, you can leave this one, and you can delete it here. Remove these ones. So this is for cross sections. This is for 1, this 2, for 3 up to 10. So what we want is the distance between the reaches, or distance between 1 to 2, and the distance from 2 to 3. So this is one is located as like the one side of extreme index. So if you want to calculate for the left bank, for the right bank, and for the middle, and for the right bank. So we have corrected last time. We have corrected this data to be 86. Okay. So this is for the left bank. This is equal to the distance from 1 to 2 is equal to 1 minus 2, okay, which is this, and at 2 the distance from 2 to 3 is the value of y at 2 minus the value of y at 3. So this is the distance between every point. You can calculate them like this, and at the middle you have to use the middle data, but you do the calculation in the same way. Okay, so if you do the same, you have the distances, and for this one also, the right bank, you have to do the same, and you will have your data here. So here is our data, and at this particular point we have the last distances from or the distance of the cross section 10 from point of interest. Okay, so we just consider this to be the normal distance from a point of interest. Let's let it be. So now we have to arrange it in on order from 10 to 1, from top to bottom. So copy these data and come here, and if you say paste special, and say transpose, and only print the values. So here's what you have. So here is the data in order 1, 2, 3, and up to 10, but it should go from 10 to 1, because if this is your HEC RAS, we are going to add the rich lengths. So we go to table and rich lengths, and if you see the station goes from 10 to 1, because our station 10 is located here. So the data goes, okay, salam.